Hello and welcome to the University of Exeter Engineering Masterclass. You are now about to watch the Engineering Masterclass produced by Mohammed Hassan Khanjapur, who is a PhD student studying renewable energy here at the University of Exeter. The Engineering Masterclass will explore his research in tidal turbines, which can be used in seawater desalination systems, to give you a flavour of the sorts of academic research carried out in the discipline and the kind of topics you might want to study at university.
Hello everyone, welcome to this presentation. Today we want to know if it is possible to convert seawater to fresh water by using the energy from the sea. What do you think? Do you think it is possible? Now you have 2 minutes to think about it and write down your ideas. Yes, it is possible. Tidal turbine can be used to power reverse osmosis desalination systems from movements in the sea. We have 3 questions here. We want to answer them. First, what is the reverse osmosis desalination system? What is the tidal energy? What is the tidal energy reverse osmosis desalination? And be careful, we have 4 keywords here. We have to learn them. Desalination, reverse osmosis, tidal turbine, and tidal energy. I will explain all of them in this presentation. Water. Why water is very important? Why we need to make more fresh water? Because water crisis is a problem from which many societies are suffering, and it is expected to get worse in future. You will be surprised if you know that even countries that are currently rich in terms of water will face water shortage in future. That's why we are seeking new technologies in engineering to overcome this problem. Desalination. What is desalination? Desalination is a process that removes salt and other impurities from seawater. There are different desalination technologies to produce fresh water from seawater. If we find an affordable way to desalinate seawater, everybody can have enough to drink. Right. One of the common desalination methods is reverse osmosis. You can see a schematic of a reverse osmosis desalination unit here. Reverse osmosis is a process where pressurized seawater flows through a filter, separating fresh water from saline water. By adding an external pressure to one side of the filter, clean water will flow to the other side. The product of the reverse osmosis process is fresh water and the brine with high salinity. For providing the required pressure for reverse osmosis filter, we need so much energy. Most of existing desalination plants in all around the world are using fossil fuels, which causes global warming. That's why we need to find better options. We need to find clean, renewable energy. Tidal energy. Tidal energy is an energy powered by the natural rise and fall of ocean tides and currents. It is renewable source of energy. It is environmentally friendly, at least in terms of emitting zero greenhouse gases. Tidal energy is predictable, and also it doesn't take up that much space. Actually, we don't need to use our lands to produce energy. Tidal turbine. Tidal turbines generate energy from currents in much the same way as wind turbines. You may see wind turbine around your city or in movies. In same way, tidal turbine can convert tidal energy to kinetic energy, to useful energy. Wind turbine convert wind energy to kinetic energy, to useful energy, to produce, for example, electricity. When we put this turbine in a sea, we can produce kinetic energy which can be used in desalination system. You remember that in reverse osmosis desalination system, we need energy. So we want to provide that energy with a turbine, with a tidal turbine. Finally, we can combine reverse osmosis desalination unit with a tidal turbine to make fresh water. As you remember, reverse osmosis desalination systems need too much energy. A tidal turbine can be used to provide that energy. When we put a tidal turbine in a sea, it can convert movement of the water to a useful energy. With that useful energy, we can power a pump, and with a pump, we can provide the required pressure to reverse osmosis desalination system for making fresh water. So, problem solved. Yes, it is possible to make fresh water from movement of the sea. You can find so many other challenges, other problems can be solved by engineering. You can discuss with your teachers, your parents, and find other problems which can be solved by engineering. I always say that engineers are creative problem solvers. Thank you.
Hiya, welcome to this 10-minute talk about studying physics and engineering at university from the perspective of me, an engineering student from Wales. So my name's Thomas, I'm an engineering student at the University of Cambridge. I'm in my 4th year now. And I come from Ynys Môn and went to school in Bangor in a school Tryfan, where I studied maths, further maths, chemistry, physics and the Welsh bac. And it's worth saying actually that I hadn't decided that I was going to go and study engineering at university, or that I was going to apply, until probably the end of year 12. And before then, kind of maths and physics was still very much on the table. I considered all manner of science subjects really. Beyond being pretty good and enjoying maths and physics and stuff at school, my interests were in renewable energy, and so I very much approached engineering with that angle. It's worth saying I actually applied to general engineering courses or integrated courses because I couldn't decide if I wanted to study mechanical or electrical or aeronautical engineering, etc. And maybe that's a question that's on some of your minds, and maybe that's something I can help with in this talk. So these subjects that I'll be covering boil down more or less to physical natural sciences and engineering. And there are some universities where you can basically just go to study those very broad subject areas, and then of course you specialise as you go on. So Cambridge, with both natural sciences and engineering, is an example of that, where I study. And some other universities you'll maybe start a little bit more narrow, studying with chemistry or physics, or studying mechanical engineering or civil engineering right from the get-go. Although in my experience actually, studying this kind of choosing universities with these broad scopes, it doesn't tend to mean that you lose that much in terms of depth, because actually that kind of first year content, when you study kinds of everything, there's a huge amount of overlap, and the same basic principles, the same basic methods are used in all of them. Computer science, I suppose, is another one, but I mean the kind of programming skills, just like with maths, are things that you will learn in a physics and engineering course just as much. Although if you're really, really interested just in programming and computers, go and study computer science. If you're really, really interested maybe in the fourth dimension or in proving theorems, then I think a maths course is more for you. If you prefer maths to actually just using maths to do something else, then maybe consider studying maths. But I'm going to talk about physics and engineering. So to give you an idea of the kind of modules and the kind of level of specialism that you get in studying these subjects, just thought I'd start with maybe examples of modules that I studied in my first year. So I had 4 papers in my first year. First one was mechanics and thermofluids, then structures and materials, circuits and electromagnetism, and then a maths paper. So that was 4, all quite broad topics. It will be the same roughly across all kinds of engineering courses. And then there'll be a few practical skills on the side, maybe some kind of like drawing both by hand and by computer, and programming. Programming is taught in all maths and physics courses these days. The language that is used may vary by course and by university, but programming is really handy, just if nothing else, just in terms of like doing calculations for you and visualizing data. It's a super useful tool. And now examples of my 4th year modules where I am now, much more specific. Renewable electrical power is one of them, sustainable water management, nuclear fusion and fission systems, and even some kind of more what we call management modules. So accounting and finance is one of them, but kind of more businessy ones that you're able to do. And these are all ones I've chosen. In my case, I chose from a kind of list of, I think, nearly 100, maybe a bit less, maybe 80 modules across that I could choose from. And I could pick and choose. I didn't have to even pick like civil engineering. I could just pick like a few civil engineering modules and a few from other places if I wanted to. So really, really like personalizable, and that tends to be the same across all like later years in physics and engineering courses. And I also have a project, which is very commonplace in terms of like 4-year courses like engineering, where in your last year maybe half your time is spent on this project, and you're the only person doing this project. And it might involve a lot of lab work. Mine personally doesn't. Very handy with coronavirus. So mine's looking at the emissions of wind turbines, for example. So quite specific. Write a big report about it in the end, a bit like a kind of a master's thesis for a kind of undergraduate equivalent of that. So what does actual studying involve? So, okay, I'm studying maths, but at school you sit in a classroom and then you do some work and then you're in a book and you go and do an exam. And actually, it's probably more similar to school than any other subject when we talk about maths and physics. Lectures, you'll have lectures, and that's where material will be essentially introduced to you. There'll be a syllabus, and the lectures will have like handouts. Maybe you have these in kind of maths and or at least physics and science subjects at school. So you're not writing all the notes yourself. You might be annotating, but diagrams and material will be provided for you. Maybe in paper or maybe online. These days everyone tends to use a kind of tablet. I've got a little pen for writing on mine here. And then based off that lecture material, you'll have kind of different lectures, different courses. There'll be like problem sheets, most likely, so kind of lists of questions for you to work through. And there might be a seminar, or in Cambridge for me, supervisions, where I can go and like ask questions, find out how to solve these problems if I didn't know, or maybe kind of stretch myself further. And exams would be very similar as well, and there'll be kind of like past exam papers as well that you could practice, just like at school, really. And then on the side, there'll be lab sessions. Maybe the labs are kind of designed to reinforce lecture material, or maybe that kind of practical skills that are actually completely unrelated. And occasionally you'll get like an essay or a presentation or something, but that's less common in my experience in first year courses. Fourth year basically depends on what you choose. You could end up very similar, or you could go down much more of a different route in terms of the modules you pick, and whether they're like more written courseworky things than exam problems. So in terms of timetables, I think kind of infamously engineering and physics have fuller timetables, much more structured. Certainly in my case, in my first 2 years, it was basically 9 till 1 in the engineering department every day. Occasionally, and that would usually be like 2 hours of lectures and then a 2 hour of something else. Maybe that was a lab, usually, or something like that. Or sometimes maybe there'd only be the 2 hours of lectures, but then like during weeks when we had like a bigger project going on, maybe a bit more 9 to 5. But it's worth noting that the idea in universities generally is that every course takes the same amount of time. Whether that actually ends up happening, it depends on the student, maybe. But if you are doing a lot of 9 to 5, I think the idea is basically that there's not too much to do, like if anything, outside of that time. And actually the amount of workload you do actually will vary week by week. So if you have a week where suddenly you have lots on, then it's going to be a bit busier. And inevitably things tend to get busier at the end of term just because, things pile up. But in general, well structured. You don't have to manage your own time quite so much. Still a fair amount though. Usually you'd be looking to try to aim to do your individual work in the afternoon. But you can still make it work around you. So obviously you'll have your fixed hours, but everything outside of that, if you don't want to do it kind of on an afternoon, you can do it on a weekend or an evening, whatever floats your boat. And assessment tends to be exams, at least in the first few years, in my experience. There might be some kind of like marked lab reports and things like that, but usually they're kind of ticking the box exercises, at least in the first few years. And so in terms of tips for applying, I really recommend you maybe consider learning some programming. Everyone gets to learn to program at university, but I really, really wish that I had actually really engaged with programming rather than avoided it before coming to university. It would have really helped me out, and actually it's really fun. So and if you're looking for a programming language to learn, Python is free, really well used, and it tends to be what's taught in universities anyway, so that's a good starting point. You need to not be afraid of maths. You need to enjoy maths ideally. It's used universally. It follows on quite nicely from kind of further maths and maths at A-level at university. You need to make sure you're comfortable with that material before you start and when you're applying. And then any competitions, lectures, masterclasses, summer schools, all of this stuff is a gold mine for personal development, experience, university application help. It's brilliant. So get involved with all that. And those of you doing back individual investigations, try and do it on something you're interested in this area as well. That'll help. And maybe just the final word on career types. Obviously, if you want to be an academic in these subjects or a scientist or an engineer, these are the perfect courses for you, but it's not the only thing, right? Also, students who go and work in the finance sector start in engineering because it's very, and science, very analytical. You're good with numbers. It's quite a rigorous course, so just kind of personally, you develop some really good kind of time management, motivational skills. And then again, there's all kinds of things. So you're looking at me who maybe might not go and work in engineering, doesn't want to go and work in finance, but would consider something completely different, maybe in government, civil service. So even like in my fourth year, you can say, I'm not 100% sure what I want to do, but I'm really glad I studied engineering. It's given me some fantastic skills, and I get to work about kind of causes I really care about, like climate change and things. So it's fantastic, and I really recommend it. So good luck.
Gobeithio chi fwynhau. I do hope you enjoyed your first masterclass full of interesting ideas. Egwyl fach nawr, let's have a short 5-minute break from the screen. Stretch your legs, take a comfort break, ac yna dod nôl i'r lobby. Come back to the lobby for your next masterclass. A fydd yn dechrau, which will start at 2:55.